Hi everyone, this video is going to be on integration involving the natural log function. In order to understand where these antiderivatives come from, we first need to understand the two basic principles that we're going to be working off of when we solve these types of problems. So the first one is the most basic one, and it says that when we have 1 over x in the integrand, the antiderivative of this whole integral is the natural log of the absolute value of x plus the constant of integration c. And the reason that the antiderivative is the natural log of x is because when we try to use the power rule to integrate 1 over x, we run into issues involving denominators of 0, and it just doesn't work out that way. And similarly, when we have a derivative of a function over the function in the integrand of a integral, the antiderivative of that is just the natural log of the absolute value of that function plus the constant of integration c. So these are the two basic principles we need to be working off of and to keep in the back of our minds. Okay, so for the first example, I have the integral of secant x tangent x over secant x minus 1 dx. So the first thing we're going to need to do is we need to define u. So u is almost always going to be in the denominator when we're doing the natural log integration. So we're going to define u as secant x minus 1. Just how it is in the denominator. Next, we're going to find the derivative of u, du. So du equals, and we know from calculus that the derivative of secant x is secant x tangent x and dx at the end. And now we're just going to define dx. So we're going to solve for dx, and that equals du over secant x tangent x. All right. So now we are going to substitute that into our integral. So we are going to have the integral secant x tangent x over u, because we defined u as secant x minus 1 over here. So u, and then we're going to multiply by dx. And we define dx as du over secant x tangent x. So du over secant x tangent x. So now if we take a look, secant x tangent x cancels out because it is in the numerator and the denominator. And we are left with the integral of du over u, which is exactly what we want since du is the same thing as u prime. All right, so now we know that the antiderivative is the natural log of the absolute value of the function, so natural log of the absolute value of u plus c. And now we're going to back substitute for u, so we get for our answer the natural log of the absolute value of secant x minus 1 plus the constant of integration c. And that's our answer. All right, so in this next example, we have the integral of 4 times cosecant squared of t over the cotangent of t dt. So again, we're just going to need to define u, which is usually in the denominator. So u equals cotangent of t. Find du. Du equals the derivative of cotangent t with respect to t. So the derivative of that is negative cosecant squared of t dt. We need to solve for dt, so dt will equal du over negative cosecant squared of t. And we're just going to substitute du and dt back into our original integral. So we're going to get the integral of 4 times cosecant squared of t over u, because we defined u as cotangent t, times dt, which we also defined as du over negative cosecant squared of t. Now check it out. cosecant squared of t is in the numerator and the denominator, so we can cancel these out. And we are left with the integral of -4, because we have this negative down here hiding. We have -4 du over u. Extracting the -4 out will make our lives a lot easier. So I'm going to go ahead and do that. So we get -4 times the integral du over u. Again, du over u is exactly what we wanted. We wanted to cancel out any t's. We cannot integrate with the natural log function when we have any other variable other than u. So, and we know from the previous definition that the antiderivative of du over u is the natural log of the absolute value of u plus c. And of course, we must always add any constant that we have out front, which in our case is -4. So for our final answer, we get -4 times the natural log of the absolute value of u, which is cotangent t, plus the constant of integration c. And that is what we get for our final answer.